Edexcel IAL Jan 2024 paper of P1. So moving on to question 1, we have to find this integral. So let's just multiply it at first. I'll multiply the first two terms at first. So 2x into 3x. So I'll get 6x squared. Then I'll have 2x into plus 2. So plus 4x. Then you'll have minus 5 into 3x. So minus 15x. Times minus 5 into plus 2, so minus 10, 2x plus 5 dx. Then you'll have 4x minus 15x would be minus 11x, minus 10, 2x plus 5 dx. Now we multiply this with this, so we'll have 6x square into 2x, so 12x cube. Then you'll have 6x square times plus 5, so you'll have plus 30x square. Then you'll have minus 11x into 2x, so minus 22x square. Then minus 11x into 5, so minus 55x. Then you'll have minus 10 into 2x, minus 20x, and finally you'll have minus 10 into 5, minus 50 dx. So I'll have 12x cube plus 30 minus 22x square, so plus 8x square. Then you'll have minus 55x minus 20x, so minus 75x minus 50 dx. You'll have 12 into x to the power 4 by 4 plus 8 into x cubed by 3 minus 75 x square by 2 minus 50x plus c. So if we calculate it, we'll get 3x to the power 4 plus 8 by 3x cube minus 75 by 2x square minus 50x plus c. That's the answer for question 1. 2, we are given the following information. AB is 15 centimeter, AC is 25 centimeter. The angle BAC is not given, and the area of the triangle is 100 cm square. So we know that area is half into side A into side B sine theta. So in this case, if we know this length and this angle, we can find out the area of the triangle. So in this case, the area is given. So 100 equals to half into 15 into 25 sine theta. Since the angle is BAC, this, and we know AB, we know the distance AB to be 15 and AC to be 25. So we can find sine theta. So the value of sine theta would be 100 divided by 1 by 2 into 15 into 25. So 8 by 15. Now for part B, we are given that sine theta is greater than 90. So the basic acute angle for this would be sine inverse 8 by 15 which is 32.2 degrees. However, we want theta to be greater than 90, so it will lie in the second quadrant. So theta would be 180 minus 32.2, and we need, so theta would be 147.77 degrees, or you can just write 147.8. Now we have to find the value of BC. So if we draw a sketch of the triangle, something like this, this is A, this is 147.8 degrees, and you want this length BC. This is 15 and this is 25. So you can just use the cosine rule over here. So BC will be 25 square plus 15 square minus 2 into 25 into 15 cos 147.8 degrees. Oh, and my bad, this will be BC square. So BC square would be 1484.4, and BC we have to find it to 3 significant figures, and it would be 38.5 centimeters. In question 3, we are given y and we have to find dy by dx. So at first we'll write the numerator separately. So y is equals to 5x cubed by 2x square minus 8 by 2x square. So y is 5 by 2x into minus 4 x to the power minus 2. So if we differentiate this now, dy by dx would be 5 by 2 minus 4 into minus 2 times x to the power minus 3. So dy by dx would be 5 by 2 plus 8x to the power minus 3. Now in part B, we are given a point P which lies on the curve, and we have to find the equation for the tangent. So the gradient P is 2, 4. So at P, gradient would be 5 by 2 plus 8 into 2 to the power minus 3. So the gradient would be 3.5. Now we can use the equation y minus y1 equals to m x minus x1. This is our yx1 and this is our y1. So we can write y minus 4 equals to 7 by 2 x minus 2. This is 7 by 2. So y minus 4 would be 7 by 2x minus 7. So we multiply both sides with 2, we'll get 2y minus 8 equals to 7x minus 14. We want to get rid of this because we want a, b and c in integers. Now I'll move it to the right. So we'll get 7x minus 2y minus 6 equals to 0. We have to substitute p equals to 2 to the power x and show that this equation over here turns to this. So let's begin. We have 2 into, we can write 4x, 4 to the power x as 2 square to the power x. We can also switch the 2 and x, so we can write 2 to the power x square So we'll write 2 into 2 to the power x whole square minus this one over here, 2 to the power x plus 3. You can write it as 2 to the power x times 2 to the power 3. So basically 8 into 2 to the power x. So we can just write this here as 8 into 2 to the power x. On the right hand side you have 17 into 2 to the power x minus 1. So you can just write it as 17 into 2 to the power x into 1 by 2, or 2 to the power minus 1. So we'll write equals to 17 into 2 to the power x into 2 to the power minus 1 minus 4. So now we can replace 2 to the power x with p. So you'll get 2p square minus 8p equals to 17 by 2p. I'll get 17 by 2p minus 4. Move it all to the left side. You'll get 2p square minus 8p plus 17 by 2p minus 4 equals to 0. To get rid of this 2, I can multiply the whole equation with 2. I'll get 4p square minus 16p plus 17p minus 8 equals to 0. So finally we'll get 4p square plus p minus 8 equals to 0. This would be a minus. So this will be minus 33p. Now we have matched it. So we have shown part A. Now moving on to part B, we have to solve this equation. So we'll just solve this. We'll have to use the quadratic formula over here. So basically minus 33 plus minus root over. If we're wondering, we are using this formula, x equals to minus b plus minus root over b square minus 4ac by 2a. This is a, this is b, and this is c, with the signs as well. B square will be minus 33 square minus 4 into 4 into minus 8 divided by 2 to the 2 into 4. You'll get p equals to 33 plus minus root over plus root over, and you'll get 8 over here. You can keep it in this form and just write 2 to the power x equals to, we cannot take both solutions. I made a silly mistake over there. I forgot to flip this sign as well when switching sides. So this will be plus 4 and this will be plus 8. So in part B, we can just solve 4p square minus 33p minus 8 equals to plus 8 equals to 0. So we can take 4p square 4 into 8 is 32. So we can just write this as, we'll do the middle term. So we can write minus 33p as minus 32p plus minus p plus 8 equals to 0. So you can take 4p here, p minus 8 minus pp minus 8. You'll get 4p minus 1 times p minus 8 equals to 0. So we'll have p equals to 1 by 4 or p equals to 8. So either 2 to the power x is 1 by 4 or 2 to the power x is 8. So x is minus 2 over here and x is 3 over here. You can just see this directly, or if you want to calculate this, you can bring in logarithms. So you can just write this as x equals to log base 2 of 1 by 4, which is minus 2, and this as log base 2 of 8, which would be 3. Now moving to question number 5. We are given that a straight line L1 passes through the points P and Q. We have to find the equation of L1 in part A. So we can just find the gradient using y2 minus y1 divided by x2 minus x1. We'll get, I'll consider Q as 0.2 and P as 0.1, so you'll get 6 minus 9 divided by 10 minus minus 2. So the gradient will be minus 1 by 4. Now for the equation of L1, for L1 we'll just use this equation again. So y minus 9 is equals to minus 1 by 4 x plus 2, x minus minus 2, which would be x plus 2. So y is minus 1 by 4x minus half plus 9. So y would be minus 1 by 4x plus 17 by 2. Now in part B, we are told that the straight line L2, this line, passes through the origin and is perpendicular to L1. So we know that if something is perpendicular to another thing, the product of their gradient would be minus 1. So gradient of L1 is minus 1 by 4. Gradient of M2, we don't know that yet, but we know that they are perpendicular to each other. So M1 into M2 should be minus 1. So minus 1 by 4 into M2 would be minus 1. So gradient of L2 would be 4. And we also know that it passes through the origin. So we can take the origin as x1 and y1 in the case of line 2. So for line 2, we will have an equation that will be y equals to 4x. Now we need to find the intersection point between line 2 and line 1. So we'll have to set y equals to y. So we'll get the equation of this equals to 4x. This would be equals to 4x. Now I can move the minus 1 by 4x to the right. I'll get 17 by 2 equals to 4x plus 1 by 4x. Then if you find yx, it would be 17 by 2. Let's just do it. 4.25x equals to 17 by 2. X is equals to 2. Now we can just find the value of y. I'll just plug it in here. So if x equals to 2, y would be 4 into 2. So y is 8. So the coordinate of r is 2, 8. Now for question C, we have to find the area of OPQ. The area of this triangle. Okay, so for this triangle, if we consider this to be the base, and this line is perpendicular because L1 and L2 are perpendicular, so this is a 90 degree. Then if we consider this to be the base, this will be the height. So we know that r is 2, 8, q is 10, 6, and p is minus 2, 9, and this is 0, 0. So the height will be OR. So the height of the triangle would be OR, which would be, the magnitude of OR would be root over 2 square plus 8 square. Root 17, and the base of the triangle would be PQ. So PQ is the base. It'll have 10 minus, so PQ would be root over 10 minus 2 whole square plus 6 minus 9 whole square. We'll get 3 root 17. So PQ would be 3 root 17. So the area of the triangle will be half into base 3 root 17 and height 2 root 17. So we'll get 51 units square. That's it for question 5. Now moving on to question 6. We are given a graph of 5 cos x. Now there's a minimum point on C1. So this is a minimum point. We have to find the coordinates. So we know the y coordinate would be minus 5. The if it was a graph of cos x, it would be like this. 1, 2, 3, 4, 5. Would be like this. Now for 5 cos x, the amplitude would be 5 times of this. So this will be minus 5. And now for cos, this is 0. This is 90 degree. This is 180. This is 270. this is 360, this is 360 plus 90, so we'll have 360 plus 90, 450, and this would be 450 plus 90. You could do it much more easily. So you see, one box would be 90 degrees. So this is how many box? 1, 2, 3, 4, 5, 6. So the x coordinate of this would be 6 into 90 degrees, which would be 540 degree. So the coordinate of P would be 540 degree, comma -5. Now in part B, the point Q lies on a different curve C2. We're given that Q is a maximum point on the curve. And we have to find the maximum point with the smallest x coordinate. We are given the equation 5 cos x minus 2 for B1, y equals to 5 cos x minus 2. So we can treat it like a transformation of the graph we had. So if we have a minus 2 after 5x, 5 cos x, it would basically mean that the graph is moving down by 2. Every y value is being subtracted. So this will go here, this will go here. So a new graph, we can plot this. This would be over here. So a graph like this. And we need to find the smallest coordinate with x greater than 0. So we cannot take this point. This point is 0, so we cannot take this. So we'll have to take this point. This is the point we want. So this is 90, this is 180, 270, and this is 360. So our maximum point will be 360, 3. So this is 3. For this, Q will be 360, 3. Now in question B2, we are given the equation minus 5 cos x. So it will be a reflection of the initial graph we had along the x-axis. So every y value will be flipped. So plus 5 will become minus 5, minus 5 will become plus 5, and so on. So basically almost like a mirror image. It will be a mirror image of this, and this would be the mirror. The x-axis will act like a mirror, and we'll get a mirror. So this is the first positive maximum, and it occurs at this is 90, this is 180. So 180, 5. That's it for question 6. Moving to question 7. In part A, we have a sketch of y equals to 4 by x minus k. So we'll have an y asymptote at y. We'll have a y asymptote at this is the equation. So we'll have a y asymptote when x minus k equals to 0. So at x equals to k, we'll have an asymptote, and at y equals to 0, we'll have an asymptote. So we also need to find any point where it cuts the coordinate axis, and the equation of the vertical asymptote. The vertical asymptote is yx equals to k, and this is the horizontal asymptote. So let's just draw it. This is the x-axis and this is the y-axis. We are given that k is positive, so the asymptote will be somewhere over here. Now we need to find the coordinate of this point, so let's just calculate it. So at this value x is 0, so y is 4 by 0 minus k, so y equals to minus 4 by k. So this is minus 4 by k. Since they want the coordinates, you can just write, for safety you can just write it down like 0 comma minus 4 by k. Now we are given that the straight line with equation 9 minus x does not cross or touch C. So 9 minus x will be a graph like this. So we have to ensure that let me select that. So the graph will be something here. The value of k will be such that the line is somewhere over here and does not touch or cross any of the other ones. So this is 9. You don't have to do it on the graph. You can just do it algebraically. So the first equation is y equals to 4x minus k, and the new equation is 9 minus x. So for them to intersect, y is equals to y. So 4x minus k equals to 9 minus x. Now we can multiply this. You can send it on this side. Multiply both sides with x minus k. We'll get 4 equals to 9 minus x into x minus k. So we'll get an equation 4 equals to 9x minus 9k minus x square plus kx. Now if we move it to the left hand side, we'll get x square plus, we'll get minus k plus 9x plus 9k plus 4 equals to 0. Now we need the determinant of this to be less than 0. If the determinant is 0, it will touch. If the determinant is greater than 0, it will cross. The difference is this. If it touched the graph, it would look something like this. If it crossed the graph, it would look something like this. So this is the difference. But we want a situation where something like this happens. So we need the determinant to be less than 0. So b square minus 4ac less than 0. B square is k plus 9 whole square. And then you have minus 4 into 1 into 9k plus 4. And you have this less than 0. So you'll have k square plus 2k in 2 into k into 9, so 18k. Then you have plus 81. Then you have minus 4 into 9, so minus 36k, minus 16 less than 0. So you'll get k square minus 18k plus 65 less than 0. Now if we break this down in, we'll get, if we factorize this, we'll get k square minus 13k minus 5k plus 65 less than 0. So k minus 13 into k minus 5 less than 0. So there will be an intersection at 13 and 5, and we need less than 0, so this region. So k will be between 5 and 13. Now moving on to question 8. We have this shape. And we have a top view. The word plan means top. So we have a top view of a platform. And it says that there is a sector DOC of a circle with center O joined with sector AOBEA of a different circle. So a different radius, but they have the same center. We are given angle AOB, which is 0.8 radian. So angle AOB, this is 0.8 radian. The arc length CD, so this arc length will be 9 meters, and the ratio of DA is to AO, this is to this, will be 3:5. Now in question A, we have to show that AO is 7.03 meters. So at first we can find out the radius OD, since we have the arc length and the angle. So we know that r theta equals to the arc length. So arc length is 9 meter. So we don't know the value of r, but we know the value of theta equals to 9. So instead of radius, I can just write OD equals to 9 by 0.8. So I'll have 11.25. Now we are given AO is to AD. So OA by OD will be 5:5 plus 3. We know the value of OD, so instead of OA, I'll just write AO and DO just for convenience. So AO by 11.25 is 5 by 8. So AO is 5 by 8 into 11.25. So this would be 225 by 32, which rounds down to 7.03 meters in 3SF. And we had to show this, so we have shown part A. Now part B, we have to find the perimeter of the platform. So if this is 0.8, this angle will be 2 pi minus 0.8 radians. And for this, the radius is 5. Oh my bad, the radius is 7.03. it's better to use the exact form, 225 by 32. So this radius is 225 by 32, and this radius over here this is 11.25. We also need this length because we have two of this lengths plus the two arc lengths. So this will just be 11.25 minus 225 by 32. So let's write down the perimeter. We already have one of the arc lengths given, which is 9. Then we'll have two of these straight lines. So 2 times 11.25 minus 225 by 32 plus r theta for the smaller sector, for the smaller radius sector. Radius is 225 by 32 and the angle is 2 pi minus 0.8. So 225 by 32 into 2 pi minus 0.8. We have to give the perimeter to 3 significant figures, so I'll just calculate that. It comes down to 56.0 meters. Now in part C, we have to find the total area of the platform. So the area of the two sectors. So area of a sector is half r squared theta. So half for sector OCD will have an area of half into r square 11.25 square into theta, which is 0.8, and for the other sector will have half into its radius, which is 225 by 32 squared, into its angle 2 pi minus 0.8. We also have to give we have to give this to the nearest whole number. So I'll calculate this. So the answer will be 186. The actual value comes out to 186.2. Since we want the nearest whole number, we'll round it to 186 meters squared. So that's it with question 8. Now in question 9, we are given that y equals to f of x, and f of x is a quadratic expansion with a maximum turning point at 2,20. A quadratic has a maximum if it's a minus x square curve. Oh, it also passes through the origin. So, and now we have to sketch the C1 at first. So let's draw the axis. We are given the maximum turning point, which is 2,20, somewhere over here, and we're told that it passes through the origins. Graph like this, and this will be 2,20. We'll also have to find, we already know this point is 0, 0. We have to find the coordinate of this point as well. So let's we can use the fact that quadratic graphs are symmetric around the maximum point. So this has a distance of 2, so this will also have a distance of 2. So this point over here will be 4, 0. So we'll have to use symmetry here. Now we have to find an expression for f of x. So we can write f of x as k times x minus 4, and we know that f of 2, which is k times 2 into 2 minus 4, is 20. So we can find the value of k from here. Oh, there will also be a minus sign over here because this has a shape like this. So this is the shape for negative x square. So the value of k would be 2 into minus 2. So k will be 20 divided by 4. K is 5. So f of x will be minus 5 x times x minus 4. You can keep it in this form or write it down like this: minus 5x square minus plus 20x. Either of this form would be correct. Now for part C, we are given that car with this equation, they meet at the origin and at points P and Q. Given that the x coordinate of the point P is negative, we have to find the coordinate of P. So y, for intersection, you will say y equals to y minus 5x square plus 20x equals to x times x square minus 4 and on I'll write the former form. I can take this to the right side. I'll not cancel x directly because it's a variable. So I'll get x square minus 4 plus 5x x minus 4 equals to 0. We'll get a cubic to solve. We'll have a cubic here, x cube minus, we can work, we don't have to solve the cubic. We can take x common over here and we can just write down x square minus 4 plus 5 times x minus 4 equals to 0. So x over here, and then you'll have x square minus 4 plus 5x minus 20 x times x square plus 5x minus 24 . We'll get x minus 3 times x plus 8 equals to 0. X is 0, 3 and minus 8. Since the x coordinate of P we are told is negative, we'll take this value. So for P, x equals to minus 8. Now we have to find the y value for this. So we can put it in either equation. I'll do it in this. We'll get minus 8 times minus 8 square minus 4. So y equals to minus 480. So p's coordinates are minus 8 comma minus 480. So that's it for this paper. Oh, we have question 10. My bad. In question 10, we are said we have a curve y equals to f of x. We are given that this point lies on C, and we are given f prime and f double prime. We are also given x is greater than 0. So if f prime x, we are given f prime x to be 4x to the power 3 by 2 plus kx to the power minus 2. So f of double prime x will be 6. So basically 4 into So 4 into 3 by 2 x to the power half plus minus 2k x to the power minus 3. So we'll have 6 x to the power half minus 2 by x cube. Now we are given at P f double prime x is 0. So if we put x equals to 2, f prime of 2 is 0. So we know f prime x, we have a k over here as well. We know that f double prime 2 is 0. So 6 into root 2 minus 2k by 8 2 cube is 0. So we can solve this to find k. So 2k by 8 is 6 root 2. So 4k is 6 root 2. Hence k is 3 by 2 root 2 or 3 root 2 by 2. Oh, we don't, this is 1 by 4, k equals to 6 root 2. So k will be 6 into 4 into root 2, so 24 root 2. Silly mistake from me. Now in part B, we have to find f of x. So we'll have to integrate this after putting the value of k. So after using the value of k, f prime x will be 4x to the power 3 by 2 plus 24 root 2 into x to the power minus 2. So we have to find the integral of this to find f of x. So we'll have 4 into x to the power 5 by 2 divided by 5 by 2 plus 24 root 2 into x to the power minus 1 by minus 1 plus c. So we'll have 4 into 2 by 5 8 by 5 x to the power 5 by 2 minus 24 root 2 x to the power minus 1 plus c. This is f of x. We can calculate c as well because we know f of 2 is 8 root 2. So f of 2 will be 8 root 2. F of 2 is 8 by 5 into 2 to the power 5 by 2 minus 24 root 2 into half plus c. This is 8 root 2. So c will be 8 root 2 minus 8 by 5 into root over 2 to the power 5 plus 12 root 2. So c will be 8 root 2 minus 32 by 5 root 2 plus 12 root 2. C will be 8 minus 32 by 5 plus 12. 68 by 5 root 2. So f of x would be 8 by 5 root over x to the power 5 minus 12 root 2 by x plus 68 by 5 root 2. So this is the answer for 10B, and that's it for this paper.